Hey, hello guys. Good morning and welcome to another session of TV Liceo. This time I'm here with you again. In this occasion we're going to talk about physics. And as you may remember, in the first time that we were talking here, or when we were with the teacher of music and with the teacher of choir, we did a lot of different things. I enjoyed that session a lot. And now I'm going to try to do something very similar. I have different props here that I will use to explain different concepts later. But anyway, today the subject or the topic that we are going to be discussing right now is one of the most fundamental things in physics, one of the most important. And first, I would like to pose here a question, maybe kind of a challenge. I'm going to start with a little story, and you will have to tell me later, or maybe you can find out during the process of the story, what is it about? Who are the real characters? I'm going to change kind of the names of the people here. I'm going to kind of change the names of the characters. And you will have to tell me, you will have to try to discover what am I talking about and what is all of this about, okay? So, guys, I'm going to start with my story. This story is going to start in a forest. In this forest there was kind of a very wise man, and that man had 3 daughters, okay? And particularly, this forest, as maybe you can see in the image, was a very special kind of forest. It was an apple forest, okay? So this wise man lived there with his 3 daughters, and these 3 daughters were very famous and very well known among the people of the village around, because they were so beautiful. And they had a lot of wisdom also. His father transmitted that wisdom, and these 3 sisters, they were all beautiful, and they all have this wisdom that I'm telling you about, okay? So I'm going to try to describe a little bit more these 3 sisters. We're watching the image here about those sisters. And okay, I'm going to start with the first one. The first one, I'm going to try to give you clues about the names of the first ones, about all of the sisters. I'm going to start with this first one. The name of this first sister is going to be Inertia. That is the name of this first sister. Let's call her Inertia, okay? And besides of being very beautiful, besides of being very wise, she had a kind of another issue. Let's say she had another issue. She was really lazy. She didn't want to do anything. She didn't want to move. She didn't like that at all, okay? But something special happened once somebody convinced her of moving. That being the case, if she started moving, it was really hard to make her stop again. So she would move around. Anybody could stop her unless someone else finally get her and tell her like, no, go back to sleep. You're moving too much, okay? And then she came back to that first state, or that first stage of laziness, and I don't want to move at all, okay? I don't want to do anything. And okay, that is one of the issues about the first sister, Inertia. That is what I am going to call her. Now, the other sister, the middle one, I'm going to be representing her with this kind of toy here. The next one is called Accelerandra. Okay, that's the name of this second sister. Accelerandra had another issue besides being beautiful and wise. She had another kind of issue, and the issue that she had is that when she was little, when she was very little, she used to go to the town very near to the forest, and she'd like to see all of the food that existed there, but especially she found sometime one dish that she fell in love with, that it was tamales. She liked a lot the tamales. Okay, so she started to be interested in that, so she could prepare them at home. So she started to work with a lot of mass to make the tamales, and suddenly she started also eating all of that mass, and yes, she was getting bigger and bigger. And at the beginning of the times that she was going to the town. I'm sorry. Oh, Accelerandra. Nothing happens. Oh, as you can see that part of Accelerandra, she was going for the tamales to the town. And did you notice that this part of Accelerandra was really quick, right? Was very fast, because it is a very small part. So when she was little, she could move, or one of the particularities of Accelerandra is that when she was very little, she could move so fast that she was known as the fastest girl in all the forest, okay? But then this other thing happened. She started to incorporate more mass into her body, so she ended up like this. And therefore, since she didn't make any kind of exercise, so their muscles were the same, and it was a lot harder for her to be fast. She couldn't be as fast as she was before, as the moment we saw ago when she ran away suddenly. Then she came back, but now she has a lot of mass, and she cannot move the way they used to do before, right? So this is the issue now with the second daughter here, Accelerandra. And now I'm going to present you the third sister, guys. This was kind of the hardest to deal with, because as you can say by the look in her eyes, you can tell that something is wrong, right, with her. You can tell by the look in her eyes that something is not very good. Okay, so the thing is with this sister, guys, that she will always take the opposite side to you, okay? If you tell her something, she would give you kind of the opposite thing. For example, you could arrive with her and tell her, good morning, I didn't tell you the name. That's because I didn't choose a name for this. I think that the creativity ran out, and I'm just gonna call her Rachel, okay? So if you tell something to Rachel like, good morning, she's gonna tell you, good night. Or if maybe someone was in love with her and tell her, I love you, she will say, I hate you. Always the opposite side, okay? Opposite side of things. So it was very, very difficult to deal with her, with this third sister called Rachel. So, but now the things were kind of complicated with the rest of the people, but among the sisters, we are watching them here. Among the sisters, they were kind of very happy together. They understand each other, they complemented each other, and they could work very well together. And so, I don't know if I can make Ines, she doesn't want to move, right? So, Inertia, right there. So, one day, their father decided that yes, they have kind of their issues, but their wisdom, the wisdom that they have, was so great and so valuable that he decided to share this knowledge and this wisdom with the rest of the world. And by now, guys, this is kind of the end of my story. Did you manage to understand a little bit what was I talking about? This is kind of, I gave you some clues. I would like to check the comments to see if you managed to identify what was I talking about. It is, as I told you before, a fundamental, very, very well-known thing in physics. And I don't know, can you tell me if you managed to identify one of the characters who was the old man, who was each of the three sisters. And meanwhile, I can check your answer. I'm going to be preparing something here to demonstrate something about these three sisters, okay? Okay, I'm watching some of your comments here that you understood, but what were the characters? I'm sorry. What do you think there were the characters here, the ones that I was talking about? Do you have kind of an idea? If not, I don't think I can see your comments. You're saying that this was fun, great. I'm glad that you liked it, but I'm going to reveal this. The thing is, guys, that I was talking all the time about Sir Isaac Newton. He was this man in the forest. Another of the clues was she is very well known or very well related to this story about the apple, that when he saw the apple falling, he came up with this idea of gravity and all of that, okay? So the person that I was talking about here, or the main character, was Isaac Newton, and the three sisters, their daughters, or his daughters, were the three laws of motion, okay? Maybe you have heard about that, maybe you don't know very well what those about, but as I told you before, this is a very fundamental part of physics. And for example, let's identify these characters. This one, the first one, inertia, as I told you before, is the first law of motion, that is called inertia, right? The first sister that we are going to talk about here is inertia. And what was the characteristic of inertia? She doesn't like to move, right? She doesn't want to change, or she doesn't want to change her state of either of rest or motion, because if you remember, once she was moving around, it was kind of very, very difficult to make her stop. So unless something else acted upon her and tell her that enough, you can go watch Netflix again, real relaxed, okay? But something is needed for her to change that state of motion, right? That state of rest or motion. That is called inertia, and that is the first law of Newton, or first law of motion. Now, if we talk about the second sister, of the second daughter of Newton, we are going to be talking about precisely that, the second law of Newton, which is a very, very important thing. That in this law, Newton established the relationship between the mass, the force, and the acceleration. That's why I mentioned the thing about the tamales and the mass, and she gained a lot of mass. So it was more difficult for her when she gained more mass. Remember that when she was like kind of this, she ran away very fast. But now, if she, or when she has this extra mass, it's very, very difficult to move. She's going to be able to move, but at a very, very slow pace. Nothing to do with the first time that we saw her move and escape from the table. Okay, so that is the second law of Newton, which tells us about the relationship between the force, the mass, and the acceleration, okay? And now, if we identify here the third sister is, remember what was the issue with this last sister? Whatever you give to her, or whatever you tell her, she gives you kind of the opposite thing, okay? And this is known as the third law of Newton, which is called also action and reaction. For every action, there is always going to be an opposite reaction with the same magnitude but with the opposite direction, okay? So this is, Rachel, for you, the third law of Newton, action and reaction. And now, guys, I'm going to try to demonstrate these three different laws with the things that I have here. I'm going to make some room here. Hopefully Accelerandra doesn't run for more tamales. And okay, the first thing that I want to show you here, guys, is, let's suppose that now this little cup is going to be Inertia, right? As you know, Inertia doesn't like to move. She is going to fight to maintain her position when she's resting. I'm going to exemplify that here. She's going to be resting now, on the top of these cards. Okay? And as you can see here, guys, the thing that I'm about to do is that I'm going to remove the cards. And what do you think is going to happen? Inertia is over the cards. So if I move the cards, what's going to happen? It's going to depend, really, right, of different things. For example, if I start to move it very slowly, so inertia, since it's in contact with the cards, is going to move along, right? It's going to be displacing. But the force that I'm applying to the cards is very small. So I'm going to try, the thing that I'm going to try to do here is demonstrate that inertia doesn't want to move and that she will have to, or she wants to remain in the same position. So I'm going to flick on the cards and hopefully we don't break anything and inertia will fall safely to the cup that we have here, okay? So let's try to do this. Hopefully nothing breaks. And do you think am I gonna make it? Let's see what happens, okay? Oops. Sorry about that. Second try. Inertia doesn't want to move, remember that, okay? Okay, I'm going to sacrifice another one of my fingers for science. Let's see if it works this time. Let's see it. Oh my god, I can't do it. I'm going to replace the cards. I'm going to try to do it very quickly last time. I did a lot of time this morning, so my fingers might be a little bit tired. Let me check this. No, it's not working. But the thing is, I can demonstrate it with other things that I have here. Maybe at the end I can give it another try. I have a piece of paper here, guys. You may have seen this experiment with kind of a big table and fancy cutlery and all of that. But I have only inertia here, okay? I'm going to try to remove the paper and hopefully inertia is going to stay in the same place, okay? So let's try to see that. Okay, this is kind of more easy. I have like a bigger piece of paper to grab on. And yes, and you can do the same here with other things. The thing that I'm trying to demonstrate here is precisely that, the principle of inertia. The things that are remaining at rest, they want to remain in that position, right? At rest. And also the things that are in motion, they want to remain in that motion. I'm going to demonstrate that with other things that I have here, but first let me see if I can manage to do this. 1, 2, 3. Okay. You can remove this very easily because of inertia. The mass of this cup wants to remain in this same position, right? So that is kind of the demonstration of inertia. I'm going to be really sorry if I cannot make this one. I'm going to give it a last try. So let me try to do it here. And last one. No, I'm sorry guys, I'm kind of a sore loser. I don't, yes, that is kind of the perfect sound for this. Take that sound. That's what I wanted to do here, guys. So, anyway, I have demonstrated that the things that are at rest position want to remain in that state. But let me try to demonstrate the same thing about inertia with these two eggs that I have here. The difference about these two eggs is that one of them is raw. It's a natural egg, a normal, and the other one is boiled, so it's a hard egg. And I'm going to start spinning those eggs, and one of the eggs, the one that is hard, you're going to watch it that it's going to turn very easily, but once I stop the one that is the hard egg, it's going to stop completely. And when I turn the other one, since the yolk inside is loose, it can move independently of the shell. So I'm going to start rotating that, and when I stop that, since the interior of the egg is still rotating, you're going to watch, I'm going to release it, and you're going to watch it, you're going to watch how it starts spinning again. It's going to be a very short movement, but I hope that you can notice that. Let me see, I don't know which one is which. Let me start with this. Okay, can you notice that? I gave it a little, with a little bit of strength. Let me see if I can manage to. It's rotating. I stop it and it continues rotating. You see? On the other hand, this is the hard egg. I'm going to rotate here. If I touch it and I release it, it doesn't move at all. Okay? Let's see this one again. I rotate it. It wobbles a little bit because of the inside is moving. But if I stop it, it moves again. Did you see that? Okay, so that's the other thing that happens with inertia. And that we are watching here that when some things are in motion, they want to remain in that state of motion. So even if I stop the egg for a little while, it starts again when I release it, okay? So enough of inertia, because she made me suffer a lot. We're going to start with the second one, with accelerandra. That is the one that we have here. And I have a little chart here so you can watch. I don't know if you can see it very well in the camera. This is kind of the formula to calculate the acceleration. Is the second law of Newton of motion is precisely that, the relationship between the mass, the force, and the acceleration. And we're watching here that it says the more the force, or the more force, the more acceleration. And you can watch that illustrated here. The force is represented with a red arrow. We are watching a bigger force here in this case. And the mass, as you can see in both examples, is the same. But with this bigger force, we're going to obtain a bigger acceleration, right? Which is represented here with the line. If we have the same mass, but we have a smaller force, the acceleration that we are going to obtain is going to be very little, right? In comparison with this other example. But there's also another very interesting relationship here that we can see here with the same formula, only arranged in a different way. I have another one here. Now, let's see this one. Now I'm presenting here the acceleration. Acceleration equals force divided by the mass. Okay? The thing that is saying here, this formula, is that the acceleration is directly related to the force, that the bigger the force, the bigger the acceleration, but it's going to have like an inverse relationship with the mass. So as you can see, we have the mass in the denominator, and if this number is a big number, so the result is going to be that this quantity is going to be very reduced. Okay, and we are going to watch that example here. It says the more mass, the less acceleration, right? If we increase the mass, as we are watching here with this blue spot here, the greater the mass, the less acceleration we have, because it's more difficult to move more mass, right? It's more difficult to accelerate more mass. We will need like a bigger force to obtain the same acceleration. Okay, so this is kind of the second law of Newton, and I'm going to make a very, very quick demonstration here about this. I'm going to use these two balls, and I'm going to apply the same force to these balls. I'm going to use this clip. The force that I'm going to apply is the one that allows me to only, or that I get when I press this and then I release it, and I'm going to flick the balls with this. So I choose this because if I use my finger, I may not apply the same force to those two balls. I'm going to try to make them roll that side, okay? Let's see if it works. I'm going to use first or I'm going to do it first with the, I don't know if you can see that. I'm going to do it first with this. Can you see that there? Okay. And I'm going to use this force, and you're going to watch how this ball is going to be accelerated, right? So there we go. As you can see, with this amount of force, we managed to move that ball pretty far, right? So we are going to change the mass here. We have a bigger ball, and we are going to use the same force with the same clip, okay? Now let's see what happens, what kind of reaction we obtain. It's kind of difficult. Okay, did you see that? The displacement that we got here with this bigger mass was far less than the one that we obtained with this one, right? So with this, I tried to demonstrate precisely that, the second law of Newton, that the force and the mass are directly related with the acceleration, okay? The mass is inversely related to the acceleration. And finally, very, very quickly, guys, in order to demonstrate the third law, it's going to be very easy. I'm just standing here, and can you tell me if any force is acting on me right now? What do you think? Think about yourselves. You're standing or you're sitting in your place. Are you experiencing any force? The most common thing that I find out is, or that I can think of, is the gravity, right? So the third law says that for every action you must have an opposite reaction with the same intensity, right? So if you're experiencing a force of gravity, you are being pulled to the center of the earth. So in order for the third law to be fulfilled, to be accomplished, we have another force that balances that, right? We need like a reaction. So what do you think is the reaction of the gravity, of the force of gravity? That is kind of a, I don't know, maybe it could be confusing. We don't think about that. We are more used to feel the force of gravity, but about the other one that goes in the other direction, we are not very used to feel that or interpret that force. But anyway, as I told you, the third law of Newton requires that another force with the opposite direction exists, so the forces are balanced. So you're experiencing the force of gravity, and you're also experiencing a push upwards, okay? I don't know if you were aware of that, but in order for the third law of Newton to be true, that has to happen, okay? So there is these systems of two forces that are opposing each other. One is the gravity that is pulling you down, and the other one is the normal force. And with that, guys, we are going to finish this session. Thank you for your participation, and we'll see you in class later, okay? If you have any questions, you can tell me in class. So goodbye. See you later.